So we're going to start our discussion about number systems or the number system by first making sure we know how to classify numbers. Basically, numbers can fit into different categories, and we want to be able to look at a number, just define it by the type of number it is, and be able to recognize where it falls on the number line as well. So to start with, we want to make sure that we understand every number we deal with this year is going to be a real number. And that just means any number that can be visualized on a number line. Now, you may say, hey, all numbers can be visualized on a number line. That's not true, okay? So if I have a number line here, I know it's not the straightest of lines, and we mark 0 someplace, we know we have positive numbers to the right, we have negative numbers to the left. For example, we have numbers like 1 and 2 and 3 to the right. We have numbers like -1 and -2 and -3 and so forth to the left. Well, those are all numbers we can recognize are visualized on the number line, but then we have all this space in between, right? All this space in between. So a number in between 2 and 3 might be something like 2.5, whereas a number in between -1 and -2 might be something like -1.3 repeating. Those are definitely numbers that we can recognize on the number line. So I just want you to have a firm grasp of that. So from here, where we go is we begin to say, okay, well, if there's all these different types of numbers, and by the way, there's an infinite amount of numbers we can visualize on number line, then how do we begin to classify them? Well, the very basic classification of numbers is simply called counting numbers. And I like to think of counting numbers as the numbers that we can visually count on our fingers, obviously going on infinitely. So we have 10 fingers, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Simply, those are the numbers that we can count on our fingers, okay? So for example, the very first counting number would be 1, followed by 2, followed by 3, followed by 4, dot, 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 okay? Now, when we get into whole numbers, because that's the next step up, it's important for us to know what counting numbers are because we're going to use what a counting number is in defining what a whole number is. So a whole number is going to simply be any counting number and 0. So that's going to be a list not starting at 1 like our counting numbers, but starting at 0. So it'll be 0, 1, 2, 3, dot, dot, dot. And just to give you a visual on a number line, here's our number line. Here's 0. Actually, I'm going to change 0 to green. It includes 0 and 1 and 2 and 3 and everything to the right. So it includes all of these numbers, dot, 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 okay? But nothing in between, no fractions, no decimals, okay? So building from there, we started with counting numbers, counting 1, 2, 3, etc. We continued on to whole numbers, 0, 1, 2, 3, whatever. We're just going to continue expanding our number line. So we started with a number line that started at 1 with counting numbers. We expanded to starting at 0 and including our counting numbers. And by the time we get to integers, it's going to be any whole number. So notice we're going to continue to build on these definitions. It's going to be any whole number, which is just the grouping up above, well, any whole number, and its opposite. So it's any whole number, but more importantly, and its opposite. So this is interesting. We started with our whole numbers 0, 1, 2, 3, dot, dot, dot. But we're going to have to pick up all the opposites of those numbers along the way. So the opposite of 1 is -1, the opposite of 2 is -2, the opposite of 3 is -3, and we go infinitely in both directions. So look at how this expands our number line. Here's our number line. Here's our whole numbers, 0, 1, 2, 3, dot, dot, dot. And now I'm simply going to add all of their opposites accordingly. So now I'm covering not only the right side of the number line, all my positives, I'm also covering the left side, all my negatives, but still avoiding all that space in between. So that is the next thing that we have to give a definition to. So, okay, if I'm limiting myself to counting essentially on my fingers, including 0 or counting on my fingers, but in terms of negative numbers, then what happens when we start getting in between all of those values on the number line? Well, those are what we call rational numbers, okay? So rational numbers are going to be, just so you understand, they're going to be fractions. They're going to be decimals. And within decimals, we can have what we call a terminating decimal, or we can have a repeating decimal. But essentially, all of these are numbers that can be, or they're all any number. So this is our definition, any number that can be written as a fraction. Or already exist as a fraction. So I'm going to give you a couple of examples here. So I know some examples. 1/2 is a fraction. That's fine. Well, something like, I don't know, 0.75, I can write that as a fraction. I can write that as, if we know that as a fraction, we know that as 3/4. So that qualifies, okay? For that matter, something like 0.3 repeating, or even negative 0.3 repeating, we should know that the repeating decimal 0.3, or for that matter, negative 0.3 repeating, is nothing more than the fraction of 1/3. In this case, it'll be negative 1/3. Okay, so that's really important for us to understand as well. So 0.3 repeating, or negative 0.3 repeating, can be written in fraction form as negative 1/3. Okay, even a number like 12, we can think of as a fraction as 12/1. So all of these types of numbers, whether they initially appear in fraction form or not, they can be written as fractions. So that's the key thing here. So it's important that you understand how we build our definitions before I close out this lesson. Everything starts off with our counting numbers, 1, 2, 3, 4, etc. Our whole numbers just add to that list the value of 0. Our integers are going to be our whole numbers, but now picking up their opposites. And then by the time I get to rational numbers, I want you to understand that now we're beginning to fill in all this space in between with numbers that fit between all of the integers we see on a number line anyway. So it's all that space in between. Okay, so that is our number system. We need to be able to look at a number and be able to classify it accordingly in the best way or in all possible ways. So we'll do that more. And then we will continue with our exploration of the number system.